Good morning, everyone. Now we are going to start discussing this 2023 October Unit 1 paper. I think you all have answered the paper and you will have a copy with you. I sent you the copy in the previously. So we are going to start this discussion, right? So let's start from the first question onwards. I must say this in the meantime, if you have a doubt in some question or if you didn't understand anything, just raise your hand and ask me. Yeah? All right. Right. First question. Let's move on to the first question. In the first question, it says an atom of aluminium 27 isotope. An atom of an aluminium 27 isotope forms the ion Al3 plus. What is the number of protons, electrons, and neutrons in this? Now they are. We know that aluminium isotope is aluminium 1327 is given, right? So it forms aluminium 3 plus ion. And we know that when forming ions, what happens here is 3 electrons are lost. 3 electrons are given. So the protons, number of protons do not change. So the atomic number is 13. And the mass number, it also not change since the number of protons and neutrons are the same. Because there's no change happened to the nucleus. So if you consider the number of protons, electrons, and neutrons here, we have 13 protons. And in the neutral atom, we have the same number of electrons as the protons, again also 13. Then the number of neutrons has to be minus atomic, that is 40. In here also, number of protons is the 13, number of electrons. Now initially at 13, from that 13, 3 electrons have been lost. That means we only have 10 here. Number of neutrons also, it's also unchanged. It is 40. Okay, so then we can find the answer with that set of answers. What is it?
Answer D, sir.
Answer is D. Yes. Okay, correct. Right. So then let's move on to the next one. Second question. In the second question, what is the type of the p orbital and the maximum number of electrons it can hold? Sorry, what is the shape of the p orbital of the type? Shape of the p orbital. Now we know that s orbitals are spherical in shape. P orbitals are dumbbell in shape. So these are spherical. S orbitals are spherical. P orbitals are dumbbell. P orbitals are dumbbell. So the maximum number of electrons. Now in s orbital, it can possess only 2 electrons. In a p sub-energy level, we have 3 orbitals. So it can possess a maximum of 6 electrons. So the correct choice is answer D. Sorry. Not p sub-energy level. So they are asking about maximum number of electrons that can be held in a p orbital. Usually, This is one p orbital. If we consider p, there are such p orbital is some part. So if we consider p, there are three orbitals, three orbitals along x, y, and z. Here we have one. Here we have another one. Here we have another one. So each of these orbitals can possess the maximum of 2 electrons over here. So, so the answer has to be the C. Answer is C. Since there are 3 p orbitals in a p sub-energy level, it can possess a maximum of 6, right? Here it is only the 2. Answer is C. So then let's move on. Question number 3. The question number 3, what is the formula of calcium carbide? Calcium carbide, the formula of calcium carbide is CaC2. What is the formula of the carbide ion? CaC2. I think it's clear for you, I'm guessing. CaC. Usually, calcium forms +2 ion. Forms +2 ion, monoatomic ion. And to balance that +2, this also should have a -2 charge. Then that -2 charge is common for C2. Therefore, the particular ion that is present is C2 2 minus. That should be the answer. Actually, here 2 C minus ions, 2 C minus ions, but it combines together to give C2 2 minus to give the 2 negative charge. So the answer is first one. Sorry, first one is C2 minus. First answer is C. C2 2 minus. Answer is C. Then question number 3, part B. Excess calcium carbide and 10 grams of water react to form the hydrocarbon ethine. Calcium carbide reacts with water to form ethine. What is the mass of ethine that forms assuming a yield of 1%? The equation is given like this. Calcium carbide. It gives ethyl and calcium hydroxide. CaOH12. That's it. Now it says calcium carbide, excess calcium carbide will react with 10 grams of water. So the limiting here is 10 grams of water. According to the reaction stoichiometry, we see that one calcium carbide will react with one water molecule, form one ethyl and one calcium hydride. So that is the reaction stoichiometry. So let's find out the numbers of moles. 10 grams by 18, it will be the numbers of moles. So the numbers of moles of ethyl 2 will be 10 over 18. Because the stoichiometry is 1:1. Right. So no need to simplify because we need to find out the mass. Right. So the question is What is the mass of ethine that forms, assuming a yield of 100%? Now let's assume we are getting a yield of 100%. That means there's no any loss, right? If it is so, by reacting this much of moles, now calcium carbide is in excess. So this by reacting this much of moles, it will give the same numbers of moles of ethine, right? Then we had find out the mass. For that, we need the molar mass of calcium. Formula mass of calcium, calcium carbide. Sorry, formula mass of ethine, C2H2. Is given, yes, 26. Is given as 26 points. Therefore, we can find out the mole C2H2 form is 10 over 18 is the numbers of moles into molar mass, that is 26 points. So this will be the,
Sir,
yeah,
sir, isn't it 2-to-1 ratio? The water.
what is it, Pratha? I'm not clear what you're asking.
The water isn't it 2-to-1 ratio, sir? Because it's 2H.
Where-
In
the-
in the water, sir, there's a 2 in the front. So it should be 2-to-1, right?
yeah, sorry, I missed it. Sorry. So then the ratio is 1:2. I'm sorry, I missed in balance. So it's 2. Then if it is so, half of this one will be the numbers of moles. Half. That means 10 over 36. Right. So this will be the mass of C2H2 that will be formed because we know the moles. So we know that mass equals moles into molar mass. We are multiplying the numbers of moles from the molar mass. Then this will be the mass of C2H2 that will be formed. Right. So once you simplify, you will get an answer that is 10 over 36. You will get the answer like 7.2. Okay, that answer is choice A. A is the answer. Right. Then let's move on to the question number 4. Which diagram best represents the electron density map of sodium chloride? Electron density map of sodium. Now we know that sodium chloride is an ionic compound. Usually, sodium loses one electron to form sodium plus ion. Chlorine gains one electron to form Cl minus ion. As a result, what will happen? Yeah. So the ionic radius of sodium, it will get minimized. It will get reduced. Ionic radius low. It decreases, and ionic radius of chlorine gets increased because of the excess electron. Here, the ionic radius increases. Now, when forming sodium chloride, Na plus minus C minus, right? Then sodium plus ion is somewhat smaller. Cl minus ion is somewhat large. So that's how we draw the sodium chloride. If it is so, the only answer here is choice A, right? But you can argue that the answer will be C, but C cannot be there because in C it is given that the orbitals are being overlapped with each other, so that has to be a covalent bonding. So that is the structure of a covalent bonding, the density map of a covalent bonding. But sodium chloride is ionic one, therefore those two should be separately placed over there. So the answer has to be A, right? For this answer A. A is the answer. Right. So then let's move on to the question number 5. Question number 5. What type of bonding present in the compound ammonium chloride NH4Cl? NH4Cl, we know that it is formed from ammonium ion chloride ion. So that means it has an ionic bonding. So it has ionic bonding. If we consider ammonium ion, it is like this. 3 hydrogens here, 2 nitrogen covalent bonds. That is the structure of ammonia. Right. Now, when forming ammonium plus ion, don't given to another hydrogen atom and forms NH4 plus. So that means we have covalent bonding as well as dative covalent bonding as well. Right. So all 3 types of bonding are present: ionic, covalent, and dative covalent. Answer must be D. Then the question number 6. The electronic configurations of the atoms of 4 elements are shown. What is the electronic configuration of the atom of the element which has the lowest first ionization in? Right. The choices are 1s2, 2s2, 2p6, 3s2. Then B, 1s2, 2s2, 2p6, 3s2, 3p1. Right. I'll explain the theory behind here. Okay, it's like this. If we consider the orbitals, the filling of energy levels, we have 1s, 2 electrons are there. Then we have 2s, 2 electrons will be filled. Then 2p, 6 electrons will be filled. Then 3s, 2 electrons may be there. Then 3p, there are 3 orbitals. That means it can fill 6 electrons. So I'm not going to draw beyond that because all the answers are based only up to 3p. Right now, in all the answers, it has filled up to 1s2, 2s2, 2p6. So here, up to this point, it has been filled. Then the thing is, after that, first choice 3s2. Now, 2 electrons are being filled over here. So the first ionization energy means the removal of the electron from here, 1 electron from here. It is not that much easy because 2 is the fully filled shell configuration of the 3s. In 3s orbital, uh, all the electrons are filled. That means that sub-energy level is fully filled. So it's not that much easy to remove 1 electron from here. Right. So we'll see the other one, 3s2, 3p1. All right. Okay. So this electron can be removed and it can gain stability. It can gain a stable configuration by removing this electron. So the removal of this 3p1 electron is much easier than removing another electron from the previous one. It is easier than the previous one. Then C, it is 3s2, 3p2. 3s2 3p2. So what will happen? The electron will be from this state. Then last one is 3s2 3p3. That is like this. So electron is here. The electron is filled over here. So the removal of electrons are from these energy levels. Out of them, the one with the lowest energy is, that means by removing this electron, if you consider by removing this electron, it will gain again unstable configuration, not a stable one. So the atom does not like to change in that. By removing this electron also, in the previous one, by removing this electron also, it will be one configuration. That means it is not easy. Again, it will gain one configuration. Right. Then in answer B, it has 3s2 3p1 configuration. So by removing this electron, it will gain the stable configuration. So that is the one, that is the atom which has the lowest ion plus ionization energy, because it is the one which likes mostly to remove the electron. Actually, this ionization energy has a variation like this. Okay. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, like this. So 1s2, 2s2, 2p6, one configuration is sodium. Altogether, we have 10 plus 1, 11 electrons. So that is sodium. Now here, so we all have altogether we have 13 electrons. So that is aluminum. Atomic number 13 atomic number means aluminum. Now say out of the magnesium has a higher higher ionization. Magnesium has the configuration of 1s2, 2s2, 2p6, 3s. So it has higher one. And aluminum has the lowest one. Then silicon, phosphorus are the other two things. So they do have higher ionization energies than that of aluminum. So the only answer is B. For the question number 6, the answer is B. Is it clear to you, Pudal? Is that clear to you?
Yes, sir.
All right. Then let's move on. Question number 7. A direct electrical current has passed through a green solution of copper 2 chromate in the apparatus shown. Okay, so there's a negative electrode and a positive electrode, and copper chromate solution is there. Right now, copper chromate is formed by copper 2 plus ions and chromate ion. CrO4 2 minus ions. Usually, copper 2 plus ions are blue in color. Chromate ions are yellow in color. And we know that positive ions are attracted towards the negative electrode. Negative ions are attracted towards the positive electrode. Positive to negative, negative to positive. Right. In that manner, we can say that to the negative electrode, positive ions are attracted. So the positive ion here is copper 2 plus. So at the negative electrode, you will see a blue appearance. Then at the positive electrode, you will see a yellow appearance because of the chromate ions. So the correct answer is C, blue and yellow. At the negative electrode, blue. At the positive electrode, green. Yellow. Sorry, wait. At the negative electrode, blue. At the positive electrode, yellow. That is the answer. Then the question number 8. In which region of a mass spectrometer are particles ionized? Right. So in the mass spectrometer, we know that the particles ionized in the region of Q. In the region of P, it will give the ions, give the atoms. Then the particles, then they will be ionized at the region of Q. Then in the region of R, it will accelerate, and region S is where we have the detector. Right. So the answer is Q, region Q. Right. Then the question number. All right. So let's move on to the next question. Question number 9. A sample of the element chlorine, Cl2, was analyzed in a mass spectrometer. Chlorine has two isotopes. What is the total number of peaks due to ions with a single positive charge, which could be seen in the mass spec? Right. Now here, chlorine has two isotopes. Usually we know that it is chlorine 37 and chlorine 35. Chlorine 37 and chlorine 35 are the two isotopes. So they, by combining these, they can form molecular ions. By combining five, by combining two chlorine 35 atoms, it can form the molecular ion like this. Other one is by combining two chlorine 37 atoms, it can form the molecular ion like this. Then the other one is by combining 35 and 37. So it can form another molecular ion. Then what about the singlets? 35 can be formed as well as 37 can be formed. So these are the possible peaks that we can see in the spectrum. So altogether, we can see 5 spectral lines. That means answer is C. For the question number 9, answer is C. Right. So then let's move to the question number 10. Propene reacts with hydrogen chloride to form halogenoalkanes. Propene reacts with hydrogen chloride to form halogenoalkanes. Which of these steps is not is most likely to occur in the reaction? Right. So let's see the mechanism here. Propene, we have propene. Right. Propane reacts with HCl. In HCl, we have chloride ions, Cl minus ions. So what happens here is now HCl molecule is a polar molecule. So this has positive and negative charge like it's positive delta and negative. What happens? This double bond breaks, pi bond breaks, and if we come back this positive part, negative in that, then it will form a carbocation like with Cl minus. Then we know that Cl minus has lone pairs. Those lone pairs can come and attack the positive carbon. As a result, that Cl gets combined with compound CH3. CH, Cl combines over here. So out of these given steps, C is the correct answer, right? Because see, the arrow should be given from chloride ion to the carbocation. It should be given from the chloride ion to the carbocation. Therefore, answers B and D cannot be possible because the arrow is from positive ion to the negative ion. So those are rejected. And out of the A and C, now A is a primary carbocation and C is a secondary carbocation. Usually, during these reactions, the reaction proceeds through the most stable carbocation. Usually, the most stable carbocation is a tertiary. Here, we cannot form tertiary ones. So the stability changes from primary to secondary to tertiary. So the tertiary one is the most stable one, primary one is the most unstable one. Here we have the secondary one, so the reaction goes through the second. I think it's clear too. Then let's move on to the part B of the question. The reaction of propene with hydrogen chloride is an example of propene with HCl is an example of. Now the first species to get reacted with the organic compound is H plus. H plus. Since it is a positive ion, we know that it is an electrophile. If it was a negative ion, it will be a nucleophile. Since this is positive, it is electrophile. So that electrophile is being added over the double bond. The double bond is broken and this is being added. Right. So therefore, we can say that this reaction type is electrophilic addition. So the correct answer is D. Okay. Then the question number 11. Ethene reacts with acidified potassium manganate. The student makes 4 statements about the reaction. The student makes 4 statements about the reaction. So let's see the answers. The organic product can show geometric isomerism. Ethene reacts with acidified potassium manganate to give alcohol. No? Ethene is this CH2, double bond CH2. Once it is reacted with potassium permanganate, it will give compound like this. Right. So it says that the organic product can show the geometric isomerism. No. To show the geometric isomerism, we should have a double bond. The type of reaction that takes place is oxidation. Yes. This is oxidation reaction. Because it reacts with the potassium permanganate. The bond angles around each carbon atom, so around each carbon atom, are greater in the product than in ethene. No. In ethene, the carbon is sp2 hybridized. So the bond angle is 120. Bond angle will be 120. Not exactly, but nearly 120. Here it is delta H. Arrange. Delta H arrangement means the bond angle is nearly 20. So the bond angle is greater in C2H2, so C2H4, because it is sp2 hybridized. So that statement is incorrect. The acidified potassium manganate decolorizes in the reaction. No. The reason is it is not involved in the reaction, therefore it does not decolorize. Wait. Yes, it decolorizes, no? Because it will undergo it will perform this oxidation. So what will happen? The purple color gets decolorized because during the oxidation, permanganate, that means manganate 7 ion, will be converted into manganese 2 ion. During the oxidation, 4 ion get converted into Mn2 plus. So here the oxidation state is +7. It gets reduced to +2. As a result, this gets decolorized. So fourth statement is also correct. Altogether, there are two statements. Therefore, the answer has to be B. Two statements correct means answer B. Then let's move on to the question number 12. Concentration in mixtures can be given in units of parts per million. The sample of gaseous mixture contains 2.19% carbon dioxide by mass. What is the concentration of carbon dioxide in parts per million by mass in this sample? Right. It's very easy. Now it says the sample has 2.19%. That means we have, if we consider, we have 2.19 grams out of grams. 2.19 out of 100 is there. In order to express in parts per million, we have to multiply it by 10 to the power. So the answer will be 2.19 into to the power 2.19 into 10 to the power 4 is the answer. So the correct choice is answer B. Then B, a solution of lead nitrate has a concentration of 15 parts per million by mass. What is the mass of lead nitrate in 400 grams of this solution? Now, lead nitrate has 15 ppm by mass. Question is, what is the mass of lead nitrate in 400 grams of this solution? Now, we know the ppm expression. Okay. Now, we don't know the mass of lead nitrate. Same. Total mass is 400 into 10 to the power 6 is equals to the ppm value, that is 50. 15 ppm. That means 15 into 10 to the power 6. No need to multiply by 10 to the power 6 because it is given in ppm. So we are supposed to find the mass of lead nitrate in 400 grams in the solution. Once you simplify, you will get the answer as 6 into 10 to the power 3 grams. You will get m as 6.0 into 10 to the power minus 3. So that is the answer. Then let's move to the question number 13. Which solution contains fluoride ions with a concentration of 0.05 moles per cubic deciliter? Right. So first one is calcium chloride. And the other compound is sodium chloride. Calcium chloride and sodium chloride are there. You need to find out the solution with the chloride ion concentration of 0.05. Calcium chloride, it will be ionized. Give calcium 2 plus and 2Cl minus. Sodium chloride, it will ionize to give sodium plus and Cl minus. So according to the reaction stoichiometry, one of the calcium chloride will give chloride ions. One sodium chloride gives one chloride ion. Right. Now the concentration expression is P equals N over V, number of moles divided by volume, and the number of moles equal to the molar mass. Therefore, the masses are given. We can combine these two together. Finally, we can give concentration equals to divided by molar mass V. So we can combine it like that. If so, we can find out the calcium chloride concentration. Mass of the solvent will be given as 1.3 divided by molar mass of calcium chloride, that is 40.1 plus 2 chlorine ions, 35.5 times 2, 111.1 into the volume is given as 250 cubic centimeters. So that is the concentration of calcium chloride. The amount of chloride ions will be twice of that. So once you simplify, you will get an answer. One 1.39 divided by 11.1 into 200. Answer will be 0.10. Okay, so it is not the answer. Then the other one, second one, the volume is 500. So only thing that we need to change here is the volume. So concentration equals to 1.39 over 111.1 into 500 into 10 to the power minus 3 into answer will be 0.05. Okay, so that is the answer. 0.05 is the answer. Uh, so B should be the answer. If you consider the others as well, here the concentration mass is 1.46 divided by molar mass of sodium chloride, that is 23 plus 35.5, 58.5 into the volume 250. Since the stoichiometry is 1:1, no need to multiply this. You will get the answer as 1.46 divided by 58.5 into 250. 0.099. Okay. The other one is we have to replace this 250 with 1000. You will get the answer as 0.0249. That is 0.025. So only the correct answer is B. Right. That's how we find it. Right. So then let's move to the question number 14. The formula of phosgene is COCl. What is the total number of atoms in 9.9 grams of phosgene? Okay. The formula is COCl2. What is the total number of atoms in 9.9 grams of this? Right. The molar mass of COCl2 is given as 99. So first of all, we can find out uh, the numbers of moles of phosgene. Right. We can find out the numbers of moles. N equals mass divided by molar mass. So the mass is given as 9.9. Molar mass is 99. Answer will be 0.1. So we have 0.1 moles of phosgene. So we need to find out the total number of atoms. According to the Avogadro's law, we can say that number of atoms is equal to number of moles into Avogadro constant. So number of moles is 6.1. Avogadro constant is 6.022 into 10 to the power 20. That will be 6.022 to 10 to the power 22. That is the answer. So that is not the final answer. That is the number of atoms of COCl2. But one phosgene has this one carbon atom, one oxygen, and two chlorines. Also, we have four atoms. Therefore, in one molecule of phosphine molecule, so in one molecule of phosphine, we have 4 atoms. Therefore, we have to multiply uh, this value by 4. So that will be the answer. Once you simplify, you will get the answer 2.41 into 10 to the power 20. That is the final answer. So the answer is D. Correct answer is D. Then the question number 15. What is the number of structural isomers with the molecular formula C5H12? Molecular formula C5H12 is there. So let's see. Molecular formula is C5H12. Let's draw the isomers. First one is a chain isomer. 1, 2, 3, 4, 5 carbons are there. So you can join the 12 hydrogens. I'm not going to draw the hydrogens. And the other one is we are going to break one of the CH to the main carbon chain. So this carbon chain will go carbon. One is the, so at the end of each of these lines, there is the hydrogen. Huh? So this is the other structure. Then I can find another CH3 group like this. Right. So that's the only number of isomers that we can draw, structural isomers. So we can draw only 3 structural isomers. Remember that at the end of each of these lines, there's a hydrogen atom. Huh? Now you may ask, why can't we draw a cyclic structure for this one? If we draw cyclic structure, then the molecular formula will not be tally with the cyclic structure. If you like, you can draw and check whether it tallies with the molecular formula. It won't. Right. So we can draw 3 structural isomers like this. Then let's move on to the next question. Question number 16. The cyclic hydrocarbon has a structure shown. How many pi bonds and sigma bonds are present in the molecule? So let's draw the structure. And it says there are 2 double bonds like this. That means it has 2 pi bonds. 2 double bonds means 2 pi bonds are there. Then let's see what are the other elements that present here. Okay. Here, in all these places, so each carbon is bonded with hydrogens. So here, this carbon has 1. So it can bond with another hydrogen. This 2 can bond with this 2 can bond with another hydrogen atom. Here also hydrogen atom. That means altogether there should be 4 bonds. Here we have only 1, 2. Hydrogen atom. Then we can count the numbers of single bonds. The number of single bonds will be 3, 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, and 11. So it has 2 pi bonds and 11 sigma. It has 2 pi bonds and 11 sigma. Then the last one, so for that answer is A. Last one, the technician is asked to stop all reagent bottles safely. Only information about this is given like this, okay? W, X, Y, and Z are the bottles. Based on the hazard labels, which two bottles should never be stored together? Right. W is an oxidizant. The flame on the ring is the oxidizant. X is a highly flammable substance. So W is an oxidizer, X is a flammable one. Then Y is the corrosive substance, and Z is a toxic substance. Okay, so W and X are the things that we do not store together because we know that the oxidizers they will support, right? Oxidizers they will accelerate the combustion. Right? That means they will supply more and more oxygen, so it will accelerate the reaction. Therefore, oxidizers and flammable substance should not be stored together. All right. Then answer has to be W and X. Answer C. Choice C should be your answer. So then that is the end of the MCQ part. Then we can move on to the section B. That is the essay questions. Question number 18. This question is about the elements in period 2 of the periodic table. So the second period elements are given here from lithium to neon. First ionization energies of some elements in the period 2 are shown. Explain the general trend in the first ionization across the period 2. Okay, so in the previous questions also I explained this. You can say there's an overall increase in the first ionization energy across the period because the number of protons, or we can say the nuclear charge increases, but the electron removed comes from the same quantum shell can be there. That means the shielding effect will be remaining the same. So that means you can't just say that it increases. You can say there's an overall increase across the period. So your answer has to be like that. You can say there's an overall increase of the ionization energy across the period, right? As the number of protons increases, there's an overall increase across the period. But we can say the shielding it will remain unchanged. Huh? Shielding will not be changed. So second one, predict a value for the first ionization energy of oxygen. Okay, justify your answer. Predict a value for the first ionization energy of oxygen. Now we saw that the increase is it has a zigzag. So from lithium to neon, the elements are like this. So their levels of energies. Oxygen is over here. Oxygen is over here, and carbon, the color, and here. Carbon, so oxygen must reach a value that is in between carbon and nitrogen. So any value 1086 to 1086 to 1402 is been accepted. But the most correct answer is, the exact answer is 1340. That is the answer. So, but any value in between 1200 to 1350 is been accepted. Right? So you have to justify your answer. Now you can give the answer like this, and then you have to justify the answer. We can say as the electrons pair up, that means as the electrons has a full p outer shell, uh, the full p orbital, right? We can say it leads to a repulsion of electrons. Therefore, it causes a lower ionization energy box. So due to the repulsions, it causes to have a lower ionization energy box. Right. So that should be your answer. Or else you can give another argument. Now we see that if we consider the electron configuration of, that is 1 is to 2 is to 2p4, right? So the electrons are filled in this manner. 2 is 2 electrons are filled. Then 2p4 are filled like this. 1, 2, 4. Now this electron, the fourth electron, is the one which removes when forming the, to give the first ionization energy. So that removal of this electron is easy, because by removing that, it will give the half field configuration. It will give the half field configuration. That means it is more stable than the partial field configuration. Therefore, that argument too can be accepted. So that is the reason for oxygen having less ionization energy than nitrogen. Then the next one, explain the large difference. Sorry. The second ionization energy of lithium is 7,298. Write the equation for the second ionization energy of lithium. Include the state symbols. Now, if we consider lithium, lithium gas can give up one electron for lithium ion. Lithium ion and also another lithium 2 plus. Like now here they are asking equation for the second ionization energy. So this is the first ionization. This is the second ionization. So you have to give this E. That's the correct E. Right. Then explain the large difference between the first and second ionization energies of lithium. Right. Again, we can explain that from the ionization energy curve. Okay, so lithium was here. This is the first ionization energy. helium has the highest line. Right. The first ionization energy is lowest out of here. Lowest is in lithium. But once that electron is removed, it gains the configuration of helium because one electron is lost. Because in lithium, we know that it is 1s2, 2s1. Then that 2s1 electron is lost. In lithium plus, we have the configuration of 1s2. 1s2 means the s orbital is fully filled. So that means the lithium will be having the electron configuration like that of helium. That means it has the highest ionization energy because it is very much difficult to remove the fully filled electron from the 1s orbit. That is the reason. We can say that the removal of electron is from the lower main energy level of 1s. So uh, the electron is removed. The electron has to be removed from an energy level which is closer to the nucleus, right? That means the nuclear attraction to the electron is the highest over there. So therefore, it is not very easy to remove that electron. So you can organize your answer in that manner. Then let's come to the part C. Beryllium reacts with chlorine to form beryllium chloride. In the gas phase, beryllium chloride exists both as a simple molecule, BeCl2, and as a dimer, Be2Cl. Draw a dot and cross diagram of the molecule BeCl2. So it's like this. Beryllium. So we chloride. So there's a bond in between this. So we can draw a dot and cross between chlorine and then we can complete. Okay, so this is the Santos diagram of beryllium chloride. Explain the shape and the bond angle in this molecule of BeCl2. Okay, now we see the shape is linear. No? Shape is linear. Bond angle is 180 degrees because it's linear. 180 degrees. Then you have to explain it. Right? We can say that there are two repulsive pairs around beryllium. In beryllium, we have only two repulsive pairs. Or we can say two pairs of electrons, two bond pairs of electrons, anything. Therefore, to minimize the repulsions, they will be arranged in a linear form. Like to minimize the repulsions, they will be arranged in a, that should be your answer. The 2 points are there. One is there are two repulsive units or two bond pairs around beryllium. To minimize the repulsions, they will be arranged in a linear manner. That should be the answer. Then third one, draw a diagram to show how two beryllium chloride molecules bond together to form the dimer Be2Cl4. Stating the type of the bond involved. Right. Now here we have one beryllium chloride molecule. They will be combined together like this. Right. The lone pair on one of these bonds will be donated to beryllium. Here also the same. Lone pair will be given to beryllium. So the type of bond that involved here is the dative covalent bond. Dative covalent bonds are the ones that are Okay. Altogether, there are 16 marks for that question. Then let's move on to the other question. That is, many cars use fuels containing ethanol as well as hydrocarbons. The E numbers of these fuels show the percentage by volume of ethanol in the fuel. For example, an E5 fuel contains 5% ethanol and 95% hydrocarbons by volume. The brand of E10 fuel contains 92.2% of hydrocarbons and 7.80 ethanol by mass. The energy density is the amount of energy released per kilogram of a fuel burned. Energy densities of the two components of this brand of fuel are shown. Okay, so it is hydrocarbon is 46.5 and ethanol is 29.7. Calculate the mean energy density of this E10 fuel in megajoules per kilogram. Give your answer to an appropriate number of significant figures. Okay, now in this E10 fuel, we know that 92.2% is hydrocarbon and the rest 7.8% is ethanol by mass. Then by burning 1 kilogram of hydrocarbons, it will generate 46.5 megajoules of energy. By burning 1 kilogram of ethanol, it will 29.7 megajoules of energy. So we can say 92.2 is the hydrocarbon, it is 46.5 megajoules of energy. The rest of 7.8, it will generate 29.7, no? Yes, 29.7 megajoules of energy. Can divide by 100. Can divide it by 100. That will give you the answer. So you get an answer like 45,100. Sorry, not megajoules, just joules, yes. You'll get the answer as 45.19. I got wrong in my calculation. It is 45.190 megajoules. But in the question, give your answer, it says give your answer to an appropriate number of significant figures. So we can keep our answer to three significant figures. Three or two significant figures, because the lowest significant figure is second. Yeah, so we can give our answer to 45 megajoules, or we can say that is 45 megajoules. Both are accepted. Then the next question, the density of the E10 fuel is 0.729 grams per cubic centimeter. Calculate the mass of 1,500 cubic centimeters of that fuel. Now we know that density equals to mass divided by molar mass. Sorry, mass divided by volume. Shall I erase this part? Density equals to mass divided by volume. What we need to find out is the mass. So mass equals to density equals. So the density is 0.729 grams per cubic centimeter. The volume is given as 1,500 cubic centimeter. So simplify, you will get the answer as 1093.5. That is in grams. So we can give it in kilograms, like 1.0935 kilograms. So that is the mass of this coal. Then calculate the energy release when 1,500 cubic centimeters of heat and fuel is burned in excess oxygen using the answers from the above. Well, okay. If you did not calculate the value for the mean energy density, you can use 38.1, but it is not the correct value. But now we know the correct value. We got it earlier. That is 45.2 or 45.19. Right. Now we know that 45.190 megajoules is released by burning 1 kilogram. Then how much will be given by burning this much of kilograms? We can say energy released is equals to 45.190 is released by 1 kilogram. Then how much will be released by this much of? You will get the answer 49.415 megajoules. 49.41. This much of energy is released by burning this coal. Then many countries are gradually replacing the E5 fuels with E10 fuels. Explain this change might result in more sustainable fuel. Now, E10 fuel means the E10 fuel has more ethanol fraction. But we know that ethanol can be produced in biological processes like fermentation. So that is one point. We can say that the ethanol fraction in the fuel can be replaced with bioethanol. The bioethanol is produced by fermentation is the second factor. So the first fact is we can replace the ethanol fraction by bioethanol, first mark. Then that bioethanol can be produced from uh, fermentation. That means from the natural processes like fermentation. That's the second fact. Then the third fact is uh, the emission of carbon dioxide to the environment will be reduced, or we can say the emission of carbon dioxide will be minimized once we use bioethanol. Okay. So those are the three facts. Again, if you like, we can relate it with the global warming as well. We can say since the amount of carbon dioxide emission is less, the global warming will get reduced. That is also accepted. So those are the points. Then part C, the straight chain alkane hexane can be reformed to give a range of products. It was suggested that one such reaction may produce a cyclic hydrocarbon and hydrogen gas as the only product. The cyclic hydrocarbon contains a ring of 5 carbon atoms. Write the equation for this reaction using molecular formulae. State symbols are not required. Okay, straight chain alkane hexane. 6 carbons are. If it is alkane, it is C6H14. So it is reformed to give the cyclic hydrocarbon. Okay, the straight chain alkane have hexane can be reformed to give a range of products. It was suggested that one such reaction may produce a cyclic hydrocarbon and hydrogen gas as the only products. So one product is hydrogen. The cyclic hydrocarbon should have this. So it will be C6H12. So it will produce C6H12 plus H2 gas. Then, so the ring has 5 carbons. Therefore, the structure has to be now this C6H12 has a ring like this of 5 carbons. Then the 6th carbon may be attached here. CH3 group will be there. Right? The ring is there. The CH3 group will be. So that will be the structure of this carbon. So that is asking the next question. Draw the structure of the cyclic hydrocarbon formed in this reaction. So we can draw this. Skeletal formula is also this is the structural formula. The skeletal formula is like this. So this CH3 group can be attached to any of the other 4 positions as well. Huh? So either this or this, we can accept. Then the next question. Hexane will react with chlorine in the presence of UV light to form a number of products. Describe the role of ultraviolet light in the initiation step of this reaction. Right. So the initiation step is the breaking of the chlorine bonds. So this is broken like this in the presence of two chlorine is the initiation step. So describe the role of ultraviolet light in the initiation step. That is to break the Cl-Cl bond to give chlorine free radicals. So we can simply say this is homolytic fission. UV light is used for the homolytic fission of the chlorine atom. Right. So that is also another acceptable answer. But the second part should include to form the chlorine free radicals. That part should be there. So the 2 points are to break for the fission of the chlorine atom to form 2 chlorine free radicals. Those are the 2 points. Then the alkane dodecadene C12H26 is formed in this reaction. Write equations for the propagation step and for the termination step for the formation of this product. Use molecular formulae in your equation. Now, once such form free radical will react the alkane. The alkane is C6H40. The chlorine free radical that is formed. It will form C6H13 free radical. And HCl is removed. That is the propagation step. And the termination will be, so it says alkane dodecadene is formed in this reaction. So dodecadene means we have 12 carbons. That means 2 such free radicals of carbon 6 can be combined together. So termination will take place by combining those. Two of the C6H13 are combined together to produce C12 26. So that is the termination step. That's the end of that question. Then the next question. Regarding the right. So let's see the reaction. Something has happened to the video. Was it like this all the time? Give me a second. Now it's okay. Now wasn't the video clear? Yeah.
Sir, the video was clear.
All right. I think something has happened. Okay, now we can continue with the next. Right, question number 20. Now this question is about alkenes. A straight chain alkene X has a structure shown. Draw the skeletal formula of the four structural isomers of X that are alkenes do not include geometric isomers. Okay, so it's like this. So from this, we are going to draw another form. We can break this part over here like this. This is one. Right. Then another one. Again, we can break that part over here. That is another. Position of the double bond can be changed like this. That is another alkene that we can draw. Then again, we can break it from here and attach to this position. That is the other alkene that we can draw. Right. So altogether, we can draw 4 alkenes. All right. Is it clear? Explain why X can exist as geometric isomer. Because we can say there are 2 different groups on each carbon atoms in the carbon-carbon double. There are 2 different groups on each of the carbon atoms in the carbon-carbon double bond. So the carbon-carbon double bond has restricted the rotation around each other, or we can say the groups are locked in that particular given positions. Therefore, they can give geometric isomerism. I will be giving a recording of this lesson, so therefore no need to write these answers. You can watch the recording and complete the answers. Then another compound Y has the structure shown. Give the IUPAC name of this structure. Now we can see that the high priority groups, the chlorines, the private group chlorines, they are on either side of the, that means they are opposite sides. Therefore, this is E-type isomer. Cl is over here, Cl is over. So we have 4 carbons in this one. 2, 4 carbons. So in the second and third positions, we have chlorines. Therefore, this is E-type. 2 and 3 positions are chlorines. So 2, 3, dichloro. 4 carbons are there. Therefore, it is but. Double bond is in second position. So 2E. Name is E23 dichloro, but 2E. That is the IUPAC name.
Sir.
All right.
Sir.
So is there a question?
Sir, in the name, give the IUPAC.
Yeah.
Does it mean only the EZ part?
No, IUPAC name means what? Now in IUPAC name, you have to give the full name.
So,
Not only the
how do we identify if it's like a EZ or it's cis or trans?
All right. Actually, cis trans is another type of EZ isomerism. There's a double bond, it can show this EZ isomerism. Right? The EZ can be shown if there are 2 or more different types of groups are attached. Here, The cis trans can be shown only for the hydrocarbons. Now see, here we have a CH3 group. If we consider their masses, or the atomic numbers, or the molar masses, say chlorine, it has number of chlorine, for the mass of chlorine, usually 35. Molar mass of chlorine is 30. Molar mass of carbon is 12. So the one with the higher molar mass is first priority. Priority. So chlorine is the more priority group over here. Here in this carbon also we have chlorine and other CH3 group attached. Okay. So chlorine gets the priority. So here the high priority groups are on the opposite sides. Therefore, it is E type. So if it was like this, now say the priority groups are chlorines, they are on the same side. So this is Z type. Is it clear?
Yes, sir. Thank you.
Okay. So that is how we identify E type and Z type. Right. Then a student stated that compound Y has polar bonds, so it is a polar molecule. Comment on this statement. Right. So polarity can be found by the attraction of the bond towards the more electronegative. Here we have carbon and here we have chlorine. So the bond will attract chlorine, and here what we, because both are carbon, both are carbons. Here this will be attracted like now. The attractions are equal but to opposite sides. Therefore, it doesn't have a dipole moment, that is zero. Right? Dipole moment is zero. So this is non-polar. If the dipole moment is zero, it is non-polar. If we consider this compound, attraction is towards chlorine, attraction chlorine, and these are not equal. So then there will be a resultant dipole moment upward. So the dipole moment is not zero. So it has a non-zero dipole moment. Is it clear? So therefore, this molecule is polar. This molecule is non-polar. Did you get the point? Is it clear? We can say the student is correct because the alkene has polar bonds, as the CCl bonds are polar, because chlorine is more electronegative than carbon. But the molecule is non-polar because it is a symmetrical, or we can say it has no dipole moment. It has zero dipole moment. That should be the answer. Right. So then the next one, calculate the amount in moles of alpha bisabolene in 5.51 grams. That's the C part of this question. Right. So let's move on to the calculation part. It's given that 5.51 grams are there. We can divide it by the molar mass to find out the numbers of moles. Here, just divide 5.51 by the molar mass of the molecule, that is 204. No? 5.51 divided by 204. You will get an answer like 0.02701. This will be the numbers of. The second part, calculate the amount in moles of hydrogen gas that reacted with alpha biosaccharidine. Use the ideal gas equation PV equals nRT. Right. So there, to apply the PV equals nRT, we should need the facts. Right. So we need to find out the temperature. Temperature Celsius as 150. So let's convert that into Kelvin. Temperature equals to 150 plus 270. Answer will be 423 Kelvin. It is given as 152,000. Okay. That is yes, sir. Then the next one, volume. Volume is given as 1,873 cubic centimeter. So that is power minus 6. That is in cubic meters. Then we can apply P equals mT because we need to find out the amount in moles. So N equals PB over RT. So pressure is 152,000. Volume is 1,870 into 10 power minus 6 divided by RT. R is 8.3, 8.31 into 10, 423. Once you simplify, you will get like 0.08099. So this will be the numbers of. So then let's go to the next one. Question. Reduce the number of carbon-carbon double bonds in a molecule of alpha biosubline using your answers to C1 and C2. Okay. Number of carbon-carbon double bonds. Now we know that the number of moles of alpha biosubline is 0.0800992. So it says this contains several carbon-carbon double bonds. Right. Now we have found that the amount of moles of alpha biosubline is 0.02701. Then we found that number of moles of hydrogen that is reacted with alpha biosubline is 0.080992. So we can conclude that alpha biosubline will react with hydrogen and give the products. So the stoichiometry, the reaction stoichiometry, we don't know. The numbers of moles of this one is 0.0, sorry, 0.0270. And moles of hydrogen was found to be 0.08099. So if we take the stoichiometry, we can find out the reaction stoichiometry. So we can find out the ratio between these two. We can say alpha bisabolene is to equals to 0.02701 is to 0.899. So we can divide both by this small number. Once you divide, this will be 1 is to this will be 2.99 something. 2.9986. So that is approximately, we can say 1 is to, that means to react with 1 mole of alpha bisabolene, we need 3 moles of H2. Now, 1 double bond to give the alkene. That means that alpha bisabolene is 3 carbon-carbon double bond. We can say that there are 3 carbon-carbon double. We can do the simplification like that. There are 3 carbon-carbon double bonds in alpha bisabolene. Then part D, the repeat unit of the polymer is shown. Polymer polyisoprene is shown. So the skeletal formula of the monomer of the polyisoprene. Right now here, polymer is given like this. So the monomer that forms this one, by breaking this double bond, it will undergo polymerization. So the monomer is okay. So that is the answer. Then draw the skeletal formula of the monomer, right? A sample of polyisoprene has a relative molecular mass of 50,250. Calculate the number of repeat units in this sample. Right. Now we can find out the molar mass of the repeat. Molar mass of the repeat unit. So in the repeat unit, we have 4 carbons. Sorry, 5 carbons are there. 1, 2, 3, 4, 5. 5 carbons and 8 hydrogens are there. Altogether 68. It is 68. Then we can find out the number of repeat units. The molar mass is 50,250. We can divide it by the molar mass of the repeat unit, that is 68. Answer will be 738.97. So this is approximately 730. So there are this much of repeat units in that answer. Then the last part of the question. Incinerators used to dispose of polymer waste have a stream of incinerators used to dispose the polymer waste stream have a system to remove waste gases. Suggest why these systems contain solid calcium hydroxide and why it is finely powdered. The answer will be we can say in the incinerators there will be some formation of hydrochloric acid, right? Then to neutralize those hydrochloric acid, we use uh, uh, this calcium hydroxide to neutralize hydrochloric acid that is formed. So it can be the hydrochloric acid or any other acidic gas. So it can form acidic gases like sulfur dioxide, nitrogen dioxide, and any other acidic gases can be. Then why it is finely powdered? Finely powdered because to increase the surface area, we know that once the uh, particles are powdered, their surface area increases. That means the finely powdered calcium hydroxide increases the surface area, so it will quickly undergo the reaction. That means it will facilitate the reaction to take place more quickly. So that should be the answer. Right. So then we are coming to the last part of this question, last part of the paper, last question. The question is about the minerals containing metallic elements. Minerals containing metallic elements. The green mineral ceratite contains basic nickel to carbonate. Okay, the compound molecule is given. Basic nickel to carbonate can be formed by the reaction of nickel to sulfate with sodium carbonate under alkaline conditions as shown. Here the reaction is given. Calculate the relative formula mass of basic nickel to carbonate. Okay, it's easy. In basic nickel to carbonate, we have 3 nickel lines. That is 58.7 into 3. Plus, then we have 1 carbon. Well, 3 oxygens, 3 times 16. And then we have 4 OH groups. So 4 OH groups means 1 OH group has 16 plus 1, 17. So multiply by 17. Then we have 4 H2O molecules. 1 H2O molecule is big molar mass of 80. So once we add these two, once we add all these together, it will give the value that is 306 point. So that is the molar mass of this basic nickel to carbon. Calculate the atomic economy by mass for the formation of basic nickel to carbonate by the reaction. Now the mass of nickel to carbonate is this much. So in the product side, we have another product that is sodium sulfate, right? So we can find out the atomic economy. Right. So we have already found the formula mass of nickel to carbonate. Then we can find the formula mass of sodium sulfate. So that can be found, sodium is 23, such, and sulfur is 32.1. Oxygen is times. Once we simplify, you will get the answer as 142.1. Then we can find out the atom economy. Atom economy of basic nickel 2 carbonate. So the mass of that is 0.1. There's only 1 mole of that in the product side. And the whole things, that is 376.1, is the nickel 2 carbon plus there are 3 sodium sulfate, that is 42.1 times into. Then you can simplify this and get the answer. You will get an answer like 46.872. 46.872 will be the answer. So that is the atomic economy. Then question number 3, give a reason why use the term relative molecular mass is not appropriating A1. Right? Because the basic nickel 2 carbonate, it has a giant structure, or it has a giant lattice structure, because, and we can say it is not a simple molecular structure. It's not a simple molecular structure, it has a giant lattice structure. Okay. Give me a second. Right. So let's continue again. So that's the reason, because nickel 2 carbonate has a giant structure. It has a giant lattice structure, or you can say it has no. It doesn't have a simple covalence. Then part B, chemists often simplify full chemical equations into ionic equations by removing spectate ions. Give the electronic configuration of the nickel ion present in nickel 2 compound. Right. The nickel ion present in this compound is nickel 2 plus. So therefore, you need to give the electronic configuration of nickel 2 plus. Once we get 1 is to 2 is to 2p6, 3d8, 4s. So once it forms nickel 2 plus, the outermost 2 electrons are lost. This will be electron temperature nickel 2 plus. That's then second part, write the ionic equation for the formation of basic nickel 2 carbonate from nickel 2 sulfate. The state symbols are not required. Right. So you have to give just the ionic equation. Nickel 2 plus is there. Since there are 3 nickel sulfate, there should be 3 nickel ions. So it will combine with carbonate, CO32 minus, and the medium is basic, therefore we should need OH minus ions. Then it will give, sorry, water is also there. No? 4 water molecules, then it will give the nickel carbon. It is Ni2CO3OH4. Ni3CO3OH4. This will be the correct ionic equation. That means we have to remove the spectate ions. We have to remove 6 sodium ions and 3 sulfate ions. Okay, so then the last part of the question, another basic carbonate found in minerals contains the metal element X and is formed by the reaction shown. Okay. 1.995 grams of excess sulfur is reacted with excess sodium carbonate, forming 150 cubic centimeters of carbon dioxide gas at room temperature and pressure. Molar volume of gas at RTP is 24. Calculate the relative formula mass of excess sulfur using these data. So we can find out the moles of carbon dioxide formed because the molar volume is given and the volume is also given. The forming volume is 150. So first of all, let us convert the volume into cubic decimeters. So we can find out the volume of carbon. That is 150 cubic centimeters per thousand. That is 0.15 cubic decimeter. 0.15 cubic decimeter. Then we can find out the moles of carbon dioxide. 24 is the molar volume. We can multiply it by the volume. 24 into 0.1. So will be 6.25 into 10 to the power minus. Right. We have to divide because molar volume is the volume of 1 mole. In order to find out the moles, we have to divide the volume by the molar volume. Volume. So the volume is 0.15 divided by molar volume. Here the answer will be 6.25 into 10 to the power minus moles. Then we can calculate the moles of excess sulfur using the stoichiometry. See, uh, the stoichiometry between excess of O carbon dioxide is 2:1. Two is to one. Then also we can see the moles of excess of it is 2 times the moles of carbon dioxide. Answer will be 1.25 into 10 to the power minus 2. 0.0125 is the mole. That is the moles of excess of O. Then you have to calculate the relative formula mass of excess of O using these data. Now we know the moles and the mass is given. Yeah. We know that. So the mole is equals to. So we can find out the molar mass excess of O. That is, the mass is 1.995 grams divided by the numbers of moles is 0.0125. Answer will be 159.6. And 15.6 is the answer. Then reduce the identity of X using your answer to C1. Now here we have excess of on. We have found the molar mass of 100.6. And we can find out mass of sulfur. Sulfur is 32.1 plus oxygen is 16 times 4. Okay. Once you simplify, you get part as 96.1. So in excess of 4, we don't know the value of this part X. And this part is 96.1. This is equals to 159.6. So from this one, we can find the value of X, that is 159.6 minus 96.1. Answer will be 63.5. Okay, from the data booklet, you can find the molar mass 63.5 is for copper. So we can identify the element as copper. So X is copper. I think it's clear to you. So that's the end of the paper. Now we have discussed, today we have discussed all the answers for the 2023 October paper. And I'll be uploading this to the YouTube as well. You can watch the recordings from the YouTube. And please keep my channel, subscribe YouTube channel. I'll give the link to you. So we will meet again to discuss a paper like this